Hi, my name is Mark Palmquist, and today I'm going to go over how to align the center of lateral resistance with the center of effort on a multi-hull. But first, I'm just going to review how you find the center of effort on a monohull before we switch to multi-hull. So on a monohull, typically you look at the side view and you find the center of the areas of the two sails. And most of the cases, the mainsail is larger. This is the mainsail, this is the middle of the mainsail, and then you find the center of area of the front sail. And so, for instance, if this sail is 60% and this is 40, then you go, and this is X, you go 40% from this point to here, and that gives you the center of effort of the sail. And on a monohull, it's real simple. You just drop straight down, and that's where you put the center of lateral resistance, which is usually a high aspect ratio keel. Now your rudder adds a little bit of area, so a lot of times you'll move this that way just a hair. But that's basically it on a monohull. You just use the side view. Now I'm going to show you why you can't really use this method on a multi-hull. Okay, so now there are at least 3 different types of multi-hulls. There's the catamaran, the trimaran, and either an outrigger canoe or a proa. And proas can be either Atlantic or Pacific. So we'll start with the catamaran. Now the catamaran, if you push the catamaran with your finger, the center of lateral resistance is the point at which you push, and it doesn't rotate. It just moves forward, but it doesn't rotate. So that would be here. So if you push it this way, it would basically be in the middle. So actually, this should be here. So this is the center of lateral resistance of a catamaran, is right here. It's in the center of the boat. Same thing with a trimaran. The trimaran has 3 floats, and if you pushed it, it would basically, the center would be here, and in this direction, if you push it that way, it's always right down the middle. So on a trimaran, the center of lateral resistance is right here. Now, this is very interesting because on a proa, the center of lateral resistance is somewhere over here. It's not here and it's not here. It's somewhere floating in the middle of the boat. So like if I pushed here on this beam, the boat would move forward without turning. So that's it has to do with the surface area here and the surface area here and the drag of this and that. But if they're basically constructed the same, then it's just a matter of, area, just like we did with the sails. This one has more area, so this dot should be closer to the larger hull. Okay, so now imagine if you were standing in the middle of the boat where the center of effort is, or the center of mass of the boat, and you were holding a kite. And let's say like the type of kite like a kite sail would be. The kite would be at an angle forward like this. So whatever this angle is, it kind of changes on heading, but in general it's between, let's say, for the fastest boat, it would be, this would be like 16 degrees is like theoretically fastest. And for a slower boat, it could be as much as, 45 degrees. But if you take the average between 16 and 45, you end up with something in the 20s. So this would be 20 degrees. Or 25, somewhere in that range. So if you were standing in the middle of the boat and you had a kite the kite would blow this way. If the wind was coming this way, the kite would be this way. And so this is where you want the center of your sail, basically. Now, the interesting thing about a trimaran is once it gets going really fast, this hull pops out of the water, and what happens is your center of lateral resistance moves this way. So if you erase this hull and pretend like it's not there, then the center of lateral resistance becomes here. So what does that mean? So now this point is behind this line. So what people do when they're designing trimarans is they just move their centerboards forward. So they calculate the side view and then they move it forward. But this actually tells you how far to move it forward. And depending on if your centerboard is here in the middle of the hull or if it's here, you know, it would have to really move forward if you have centerboards on your outriggers, as opposed to the middle. So it would just have to move forward that much, which is a very small amount. Same thing. Okay, so catamaran, here's the center of effort. So you want the sail to pass through this point. The center of effort wants to pass through this. Same thing with this. Okay, so let's say you're heeling and this hull is no longer touching the water, then your center of lateral resistance shifts this way. So now your sail is in front of the center of lateral resistance here. Now, an interesting thing happens on a catamaran, though, because the sail force is in this direction. It tends to want to this hull wants to dive into the water. So when this hull dives into the water, all of a sudden there's more. If this is a side view of the hull, the front of the hull gets deeper in the water, and so it actually automatically shifts. The center of lateral resistance of the leeward hull moves forward as this bow tries to dig a little bit and get deeper in the front than it is in the back. So one of the ways to counteract this is just to move the sail back a little bit on a catamaran. In fact, on a trimaran as well, some of the newer trimarans, racing trimarans, they move the center of effort slightly back, and this allows them to have better balance. Okay, so now I'm shifting to an asymmetric outrigger canoe. So let's just imagine that this is the front of the boat. The boat travels in this direction. That means the sail is either going this way, or the sail is going that way, and the center of the sail is either like the lift from the center of effort is either going this direction or that direction. So if this is the center of lateral resistance, you'll notice that this, if I continue this way, this is the direction of lift, and this is the direction of resistance. And as you can see, they're not exactly lined up. And then when the boat's going the other direction, the lift goes this way. The lift is now in front of the lateral resistance. So on an outrigger canoe, this should be able to shift forward and back. So it wants to intersect this line on one tack and this line on the other tack. So depending, let's say if you're traveling this way and the wind's coming from over here, if the lift is in this direction, actually, yeah, if the wind comes this way, the sail is over here and the lift is that way. And so you want the rudder to shift backwards to hit this line. So if you look at this area right here, this is the area where you want to shift your center of lateral resistance. So it's good to have basically a board that can slide forward or back, or tilt forward or back. Tilting is probably easier, but you could also have it slide forward and back. And so that's if you want these two forces to align. You have to move you can't really move the sail. It's hard to move a sail on a tacking outrigger, but you can move the center board or the lee board. You can move it forward or back, so then it aligns with, depending on which tack you're on. Okay, now I wanted to talk about the Atlantic proa. There aren't a lot of Atlantic proas. So Atlantic proa is one where the sail is on the windward hull, and the leeward hull is usually almost as long, maybe slightly less volume. Most of the volume is usually on this one, but sometimes they're the same. Cheers is a good example of a Atlantic proa. So if I wanted to put sails on this hull, the first thing I would do is draw a line through the center of lateral resistance, which is here. And so here's my line. So it's interesting that the ideal place for the sail is basically here on an Atlantic proa, and the ideal place for a catamaran would be in the middle. I'm not going to draw that, but the ideal place for a sail on a Pacific proa is actually in the front. That makes sense, right? That's where the sail is usually positioned on a Pacific proa. You always see the sail on the front, the crab claw sail. It's always in the front. Well, this is why. It has to do with aligning with this diagonal line. So that's why on Atlantic proas, you don't really have to shunt. You don't have to move the tack of the sail. The sail can rotate basically from the center, as long as, as long as these two forces align, this dot and this center of effort align, then you can, and then if you have a schooner, you can have a mast here and a mast here, and basically it's the same deal. You got the sail here, and then you got two sails, and you have one here and one here, and they're basically still aligned with the center of the boat. But this is how you can tell where to put the sail. So you want the sail along this line. If you don't put the sail along this diagonal line, then your boat will turn. So anyway, so that's why when you see a Pacific sail, proa, the sail is towards the front of the main hull. And when you see an Atlantic proa, the sail is sort of towards the back.